Okay, so it's been a little while since we've done a video here. I'm still trying to outline this book. So we're going to kind of skip ahead because we already did an introduction to chapter 3, but we're just going to kind of roll through because we're not really sure where we left off in the previous video here. But this is chapter 3, production choices. So kind of the introduction is not too important here. So I think we went through all of this in the previous video, the previous few videos. Okay, so a big part of the entire chapter, it gets much more in depth than this, yes. But a big part of this entire chapter literally revolves around the production function. So I know that we had discussed this previously, but remember Q, which obviously is quantity, is a function of L comma K, both labor and capital. Capital they call K. So we kind of pause there for just a moment, the production function. But this right here specifically is the production function. We do a lot of different things with it, but chapter 3 revolves a lot around this one function, this one idea of the production function. Yeah, so we see the production function right here. Yeah. Okay, so we did this a little bit, but I think this is about where we left off. Marginal product and the average product. Um, So we can kind of go through this a little bit. We can read through, which wouldn't do us much good. We're just basically looking at those two equations, the marginal product of labor, the marginal product of capital. But yes, we've said it a good handful of times, and we will say it many times. Whenever we say the word marginal at all, 100% of the time in microecon, we're simply talking about a derivative, more than likely a partial derivative. Yeah. So the marginal is basically the same word as derivative, and here they are right here. The partial derivative with respect to labor and the partial derivative with respect to capital. Yeah. But what do we get? So if we understand the basic concept, we have a three-dimensional graph. We take the partial derivative, maybe we make a two-dimensional graph, yes. But if we have the marginal product of labor, the partial derivative of quantity with respect to labor, we basically can change the labor while the capital is held constant. So we want to remember that marginal product of labor is what's going on. It's the increase, just one increase in quantity with respect to one increase, or I should say it is the increase. I didn't say it very well, so I apologize. Yes, but increase Q, yeah, with one unit increase of labor. So K is held constant, yes. And then just go ahead and kind of erase that really quick. I'm trying to kind of fly through it because it's very easy. Yeah. But if we take the marginal product of capital, then Q will increase. What is the whole point? Q will increase some quantity with one increase of capital. And of course, labor would be held constant. So marginal marginal product of labor, the change in Q with respect to L while K is constant, the marginal product of capital, the change in Q with respect to K while labor is held constant, and it's just, of course, going to be the first derivative. So then that will lead, we can kind of read through, they don't really give an example, we don't need it, but we can say the concept very, very quickly, which we have done, and reading through doesn't help that much. They kind of give us an example if we ever want to take a look at that. This is going to lead into the average production of labor, average production of capital is what it will lead into. Okay, so, constant, I'm sorry, capital can be held constant or labor can be held constant, yes. So then they just kind of give us these graphs. On the left, if capital is held constant, it's the change in Q as we increase labor. And if we take the first derivative on the right, is what we had, the marginal product of labor. We can do the same with capital, but they have marginal product of labor. Yes. And we're going to do the exact immediately after this, we'll do the idea diminishing marginal returns. A return does just mean quantity Q, but diminishing marginal returns, I can't help but get a little bit in my head of myself. It just comes up next. This is, of course, the Cobb-Douglas, the all-star kind of example in this book is the Cobb-Douglas, but we notice how, of course, through the entire thing everywhere, it is concave up, but everywhere we have a negative slope. Yeah, so the fact that the absolute value of the slope is becoming a smaller number, later they're going to call that the law of diminishing marginal returns is what they're going to call that. But on the left, what we have is simply quantity as a function of labor when capital is held constant. And then if we take the derivative of that, it is the partial derivative MPL, which we just said, marginal product of labor. They're just showing us, remember the obvious, that the slope here is the y value here. The derivative is a y value. They're just showing that as we increase L, what the y value is as we increase L, but they graphed the derivative there. So like we said, what we're leading into here is the average product of labor and the average product of capital. Remember this fancy function, for those of us who are new to the three-dimensional notation, this fancy function is just Q. It's just quantity as a function of labor and capital. So average is not a thing. At any moment in time, we can kind of read through this, but this is how I understand it. At any moment in time, whatever quantity we have produced, Q is a quantity that we have produced. At any moment in time, whatever quantity we have produced and how much labor that we use, it should be obvious that the total quantity at some moment in time divided by the total labor it took to make that quantity is going to be the average production of labor. And the same for capital. Whatever the quantity is at some given moment divided by the capital used to make that quantity is the average product of capital. So fun-filled videos, just really technically talking about the simplest possible thing. We don't really need it too much. So we kind of have two different words for it, diminishing marginal product and also diminishing marginal returns, which is kind of right down here at the bottom. Yes. So I think we'll kind of do this in the next video, but this is considered a very kind of rudimentary, fundamental, and very important concept in microecon is going to be the law of diminishing marginal returns. Let's just take a look at this here. So let's kind of scroll through. We're going to continue this with the next video here. But I just want to kind of roll through and see what they do here. And then we're going to get into isoquants there. Okay, so let's kind of stop the video here and then we'll get into the other one pretty quick here.